Hello guys, Winston here. Back in February at WorkbenchCon, I was over at the Rockler booth and I saw something there that piqued my interest, a vacuum clamping system. I got to talking with one of the guys there and he agreed to satiate my curiosity by sending me a set of clamp pods and a vacuum pump. Let's get the expository stuff out of the way first before playing around with the hardware. Rockler's vacuum clamp pods come in packs of 2 for $60. They're plastic pucks about 3.5 inches square and 7/8 of an inch tall, which includes the replaceable foam gasket around the top. A little spring-loaded ball bearing controls the application of vacuum to each pod so you can set up multiple pods without needing to use all of them. You can daisy chain multiple pods together to cover a larger surface area, limited mainly by what your pump can handle. The pump Rockler sells for this application is rated to handle up to 4 pods, and it comes down to 2 things: pressure and volumetric airflow. The pump Rockler sent me will pull 25.5 inches of mercury at about 1.1 cubic feet per minute. For reference, a perfect vacuum is 29.92 inches of mercury, which I had to look up because the metric equivalent is so much nicer to remember. Now here's the number that for a lot of people will give them pause. The price of this pump is $400. Yes, you can use any other pump, and yes, there are plenty of cheaper vacuum pumps out there that will pull a higher vacuum. Here's why you may want to consider a pump like this one. Most cheap vacuum pumps are of the rotary vane type, which require oil to operate. Not only is that an extra point of maintenance, but at higher loads these units can overheat, causing all sorts of problems. Just look at Grant Thompson, who resorted to dunking his vacuum pump in snow and pouring liquid nitrogen on the casing to cool it. Both terrible ideas, by the way. Rockler's pump, which is made by Gas Manufacturing, is a diaphragm type and engineered to be able to sustain its rated output for a long time. Rockler had a unit running demos throughout WorkbenchCon like a champ. I ran mine for an hour and the temperature of the casing was what I would describe as vaguely warm to the touch. Like, if you offered me pizza that was hot, cold, or this, I would go for the other 2 slices first, so I have no concerns about this thing overheating. Anyways, my point is, the choice of pump is up to you, but you'd better do your research. Also, I do want to touch on Venturi pumps, which are pretty prevalent in machine shops. For those of you who aren't familiar, these pumps are powered off compressed air and use the Venturi effect to pull a vacuum. Long story short, air that is accelerated experiences a pressure drop. You can use that pressure drop to draw additional air with it. This creates a vacuum quite efficiently. The reason you see it a lot in machine shop environments is because the exhaust can be dumped directly into the air. Even if you're running mist coolant or something else gets into your vacuum table, there's no risk of it fouling up a pump. But the volume of air that you can move is a lot smaller. Looking at the Pearson SmartVac system, for example, it can extract air at half a CFM. If your leakage rates are low, that's fine. Aluminum and a gasket make a pretty nice seal. But if you're work holding wood, you'll probably want that extra CFM afforded by a traditional pump. Speaking of the pump, someone asked me on Instagram how loud the pump is, and it's hard to describe. So how about I just lock my camera's microphone sensitivity and turn the pump on so you have a point of reference for just how loud it is. Keep in mind that this pump was running continuously at WorkbenchCon, and people were able to just have normal conversations around it. You won't forget it's there, but the volume is pretty manageable. So now that we have that out of the way, let's see how this system works. First order of business for me is attaching the vacuum clamps to my Shapeoko. Rockler's pods have a 5-inch hole spacing and provisions for T-track installation. First off, I don't have a T-track system, and second off, I've been told that Carbide 3D's T-tracks are a little too small for Rockler's hardware. Fortunately, these holes fit standard 1/4-inch screws and I can just bolt one end and clamp down the other. One thing I wanted to assess right off the bat is how secure your workpiece is, and I don't mean whether or not you can lift a piece off the clamp. Anyone can do the pressure over area calculation to figure out how much force it takes to separate stock from a clamp. What I mean is, how's the deflection? You're resting a piece of material on a flexible gasket with no hard stops. That means if I stick a dial indicator over here, the material will roll slightly as I apply pressure and I can measure that. We're talking fractions of an inch, typically 10, maybe 15 thou, and that's like worst case scenario. You can easily control cutting forces by backing off on your material removal rates so that this doesn't become an issue. Remember, vacuum work holding has its pros and its cons. Convenience is a huge pro, but you can't expect that kind of interface to be rock solid. Thankfully, in lateral directions, Rockler's vacuum clamps show barely a thou or 2 of movement under regular conditions, and you could reduce that further by using multiple pods. Let's try a relatively straightforward woodworking application, making a sign. I'm going to throw a pine board on my array of clamps and first face it off to ensure that it's machine level. Engravings are really sensitive to height variations, so this is important. Then, once I've got everything flat, I'll stick in a 60-degree V-bit and carve some stuff in it. And lastly, I'll go around it all with a downcutting end mill in 1/16 inch passes. Not only does this leave a great surface finish on top, but it also works with your vacuum clamps by applying downward pressure to your workpiece instead of pulling it up. You'll note here that I didn't cut all the way through my board because cutting into your clamps is a really bad idea. If your sign is bigger and it overhangs your clamps, then you could actually cut all the way through your wood, but you'd better know exactly where your contour perimeter is going to be. I'll take this sign and cut it out of its little window frame, put a chamfer around its faces, and spray the front with some lacquer and paint. Then I'll come back and deck it off with my 1-inch surfacing bit. And as you can see, that's weird. I wonder why it didn't clean up the logo side of my sign. I hope these clamps are level. Let me rotate the sign and see if the left clamp is actually lower, or if the left side of my sign is just somehow thinner than the other. Okay, logo's still not getting cleaned up. That's good for the clamps, bad for me. Let's see if we can't shim up the left side with some masking tape. There we go, much better. I think when I set up my first operation, I had a third clamp that was biased towards the right, and that might have pulled one side lower than the other, especially if my board was cupping slightly, which I think it might have been. Just look at that struggle fest I had trying to get this piece to seal. So, pro tip, always use your clamp symmetrically, and make sure your boards are actually flat to start with. Now, we could just stop here, but making a sign is kinda boring, and honestly, almost predictable. You probably knew that this was going to succeed all along, so let's try something else. When I was at Rockler's booth, I was tipped off to the fact that MDF is porous. We all know it soaks up water like a sponge and it makes a terrible wax casting mold, but it's also permeable to the atmosphere. Like, if you stick a sheet of MDF on top of a clamp, air will be pulled through the MDF and you can use that to hold flat stock on top. Now, it's obviously not as secure as if you'd stuck your material directly on top of the clamp, but it can still allow you to machine something without worrying about cutting through it, or allow you to hold a piece that's too small to fit on the clamp by itself. So I'm going to start with some 1/4-inch MDF and set that on a clamp pot. I'll face it off to ensure it's machine level and then slap on some leftover brass sheet stock from a previous project. Then I'll load up a 1/16-inch end mill and try to cut something out. And I didn't quite make it. The holding force of my brass through MDF just wasn't strong enough. But we can reduce the cutting forces by using a smaller end mill, so let's break out a 1/32-inch cutter. I'm targeting 300 surface feet per minute and a chip load of 3.3 tenths, not thou, per tooth. At first I thought that was a little thin, but those were the feeds and speeds I found for a comparable end mill. This time I got through my entire program without anything shifting on me. But all was not well in the machine shop of horrors. Despite zeroing my end mill off the machine leveled work surface, there were slivers of brass that I was missing with my cuts. I tried re-zeroing 5 thou lower and I got my profiles a little cleaner, but they still weren't perfect. After some more adjustment, I finally cut through my brass completely. Trying to understand what happened, I noticed that my incomplete profiles were biased towards the center of my cutting area. And then it all made sense. When I faced my MDF, it was subjected to a certain amount of vacuum. By placing a sheet of brass on top, I was creating a better seal over the face and causing the MDF to be pulled down by a stronger force. Because the MDF was thin, it was actually bowing due to the pressure. If I throw my brass directly on top of a clamp, you can see this illustrated more clearly. So if you're trying to do what I'm doing, I would recommend using MDF that's at least 3/8 of an inch thick. Now that I have some dog tags though, I can also use vacuum clamps to help me with the engraving process. If you machine a shallow pocket in some MDF, you can use it to locate your parts quickly and repeatably. Now, while I have done engravings in the past where my parts weren't adhered to the machine, only held laterally by the walls, having a gentle vacuum drawn on your part gives you a little bit of extra insurance that it won't move. And of course, you can enhance the vacuum effect by sealing unused faces of MDF. You could do this by applying a coat of something via spray can, or what I found to be a cheaper and quicker method, by using packing tape. Now, I want to be perfectly clear, vacuum work holding is not a magical one-size-fits-all solution for CNC. Everything I've done in this video could be replicated using double-sided tape, for example. As a machinist, it's your job to look at the pros and cons of the tools available to you. Vacuum clamps can be a really convenient work holding method to give you access to the top and sides of your part. And in the case of my brass dog tags, there was no adhesive to worry about cutting into and gumming up my end mill or sticking to my cut walls. I'm more than happy to trade a minute of machining time for a minute less cleanup. So to sort of wrap everything up, vacuum clamps are pretty darn cool, and I feel like I've just barely scratched the surface of what I can do with this work holding method. But you do have to be cognizant of the compromises involved in using them. I hope this video has given you some insight into vacuum work holding. I for one am more interested now about this technique than when I started. I want to thank you all very much for watching, and also thank Rockler for sending me their vacuum clamp pods and vacuum pump for me to try out. If you want to learn more about these items, I'll have links to them in the description below. I really appreciate them standing by the community and supporting content creators like myself, so go check them out, and if you found this video interesting, let them know. I'll see you guys in a week or two with more CNC content. Also, Bay Area Maker Faire, be there or be square.